The main objective of this framework is to investigate and to develop artificial intelligence machine learning algorithms used in Wall Street applications with emphasis in stock price predictions. I have generated several machine learning Python software models, from linear regression to recurrent neural networks. Using linear regression methodology to evaluate and predict the market trend. In this application, the evaluation is done with a linear regression algorithm and the exponential moving average, EMA. Two important indicators are implemented. They are the 20-day EMA and 50-day EMA. For instance, when the 20-day EMA rises above the 50-day EMA, the stock probably trends upwards. Several algorithms based in Python software are used to provide stock price prediction. Those are models that were developed and include feed-forward neural networks, recurrent neural networks, and linear regressions, as well as linear interpolations. These are model architectures and hyperparameters that are optimized and automatically searched by evolution algorithm. The framework is set to predict the stock price for the next 10 days. 10 days is chosen as the framework, as short-term price movements tend to depend more on trend momentum and price pattern, while long-term price movements depend on fundamentals of a stock. That is, for example, company management capabilities, market demand, microeconomic factors, as well as political situations and revenue model. The loss function of the training algorithm is the mean squared error of the 10 predicted stock prices. The training algorithm, or optimizer, is set to minimize the value, and it serves as the basic performance metric for comparing the different models. Stock price prediction with big data and machine learning. Synopsis. This post is based on modeling high-frequency limit order book dynamics with support vector machines. Currently implementing ideas introduced in Scala with Spark and Spark ML library. The model architecture are proposed in this framework for extracting feature vectors from raw order log data that can be used as input to machine learning classification method, SVM or decision tree. As an example, how to predict price movement up, down, or stationary. Given a set of training data with assigned labels, that is price movement, classification algorithms builds a model that assigns new examples into one of predefined categories. Those categories are listed in a table format with time, price, volume, event type, and direction. And they're listed in this video presentation. So in the table, each row of message book represents a trading event that could be either an order submission, order cancellation, or order execution. The arrival time measured from midnight is in seconds and nanoseconds. The price is in US dollars and the volume is in the number of shares. Feature extraction and training data preparation as it relates to machine learning data software algorithms. After order books are reconstructed from order log, we can derive attributes that will form feature vectors used as input to the classification model. These attributes are divided into three categories: basic, time intensive, and time sensitive, all of which can be directly computed from the data. Attributes in the basic set are the prices and volumes at both ask and bid sides of up to n equals 10 different levels, that is, price levels in the order book at a given moment, which can be directly fetched from the order book. These attributes in the time-sensitive set are easily computed from the basic set at a single point in time. In this bid-ask prepare and mid-price, price ranges as well as average price and volume at different price levels are calculated in the features sets. To prepare training data for machine learning, it is required to label each point with price movement observed over some time horizon, for instance 1 second as an example. It's a straightforward task that only requires 2 order books: current order book and order book after some period of time. The predictive model architecture is designed based on the following methodology. The data processing consists of stack prices, preprocessor, and training data. The training by evolution of the architecture is based on the models. The train and optimization, and also by picking the best models and combinations. And finally, the prediction display to retail investors would be the model scores, the predicted stock prices, the upper lower bounds. The data pre-processing stage of the system architecture is based on several Python scripts which are written to transform the raw stock prices, that is in CSV files, into feature vectors for training, predicting, and testing respectively. These scripts take the input options and the raw stock prices as inputs and produce the proper features by building the look-back arrays and the moving averages. After, it concatenates the features into final feature vectors, which are passed to the model for training and/or testing. The scripts are shared common operations in building the data set, that is, output size and the range of dates to be built from. The NumPy and pandas are used to build the data sets, and NumPy is normally the library that provides effective n-dimensional arrays, data structures, and also functions for array manipulations. It is used for machine learning tasks because it is the performance that Python lists as NumPy arrays are implemented, and normally densely packed lists. The pandas is the framework for which I use in this design methodology in conjunction with Anaconda and Spider system interface.